Hello, in this video we will be discussing the node voltage, which is the application of Kirchhoff's current law with dependent sources, both current and voltage sources, dependent sources. So first off, I'll set up a familiar circuit here. Got our source, we give ourselves 12 volts, got a resistor here, another resistor, one here. And then instead of a resistor here, we're going to put in dependent current source. And this current source will be 4Vx. So it's a voltage controlled dependent current source. And Vx is just going to be the voltage across, oops, not 2, but X, the 2 ohm resistor. We'll add one more resistor up here. So we've got, again, V1 here. We have our second node, V2, and our third node, V3. Put some labels on these resistors, match them up to what we had before. Now, obviously, V1 is going to be really easy again. First equation, node equation 1, we have V1 equals 12 volts. All right, we've all got that. But how about for V2? Well, again, this is going to be exactly what we had in the other circuit. We'll have the current here, V2 minus V1 over 8, plus the current down through there, V2 minus 0, right, for our ground, over 2. And the last one is V2 minus V3 over 6. And this has to equal 0. So for V3 now, we've got this hiccup. We have this dependent current source. Now, what this current source is, if you recall, when they were briefly mentioned before, is the value of the current on this branch is going to be equal to 2 times the magnitude of the voltage across this 2 ohm resistor. So let's see what that looks like. N3, we'll start with what we know. Current there, V3 minus V2 all over 6. And our current here, V3 minus V1 over 10, which we add. And then the current here. And that current is just going to be negative, since we know already from the direction that the source is pointing that this is wrong. It's going to be negative 4 V2. And all this equals 0. So for this current source, this is actually pretty easy, right? All I had to do was realize that Vx is equal to V2. Sub that in. And since this is just an application of Kirchhoff's current law, where this is a current, this is a current, and this is a current, all we had to do is just sub that in. All right, so let's try a voltage-controlled voltage source. So the same circuit, plus minus 12 volts, go up, resistor here, we get our 6 ohm resistor here, and then instead of the current source, we have the voltage source. And again, for Vx, where that Vx is just the potential difference across that resistor. And we have one more parallel resistor up at the top. Same nodes. In this case, however, is it going to be easier? Yeah, probably. So N1 is equal to 12 volts. Hopefully we've all got that one by now. V2, again, V2 minus V1 over 8 plus V2 over 2 for Vx, and V2 minus V3 over 6 equals 0. Now node 3, in this case, is even easier, right? So if we already know Vx is equal to V2, then this is equal to 4V2, and we've already got it in terms of one of our other variables. So V3 is just 4 times V2. Super easy. Okay, now how about if we throw a monkey wrench in there and put a super node into this circuit using a dependent source. So we'll go back to what we had. 12 volts here. Now here, I'm going to put our dependent source plus minus, and this is going to be a current controlled voltage source, dependent voltage source. That'll be 4 times Ix. So the voltage it produces will be 4 times the magnitude of wherever we put Ix. A resistor up there. Over our label and down. So in this case we have 8, here we have 2, here we have 10, and we put in our 6 ohm resistor back. Now where's Ix? So we'll just put it back here on the 2 ohm resistor. So that is Ix. Now in this case, we have, again, 2 very simple node equations. V1, V2, V3. Since V3 is connected to that source, we can do node 1 and 2 very quickly. V1 is our old standby, our old standby 12 volts, and V3 is going to be, well, V2 plus 4 Ix. And this Ix we can already put in terms of something else, right? This voltage drop. So Ix is V2 over R. R is 2. So we can replace this down here already. I'll just erase that Ix. V2 over 2. But that's where things stop getting easy. Because again, the current here is going to be whatever it takes to get V3 equal to V2 plus 4 times V2 over 2. So we need to separate those currents out again, use our current law to find what that's going to be there. So rather than using this current, we'll just use these two. I'll sub them in as we go. To start off with, we can store on the other side V2 minus V1 over 8 plus V2 over 2, which is just VIX, plus, now we need to do the separated currents. So first one, V3 minus V1 over 10, and the last is V3 over 6. And remember, this all equals 0. And that's as hard as it gets.